We are now in Unit 4, Section 1. This is the first day of textbook Section 7.2. We're going to be graphing rational functions. So this is an example of a rational function, 1 over x. So x is in the denominator. So go ahead and complete the table of values by plugging in -3 for x for each one. All right, I'm going to pause it and let you do that. Okay, so if we look at our table of values here, we have -1/3, -1/2, -1. If I try to put 0 on the bottom here, I'm actually going to get an undefined expression. So I cannot plug in 0. It's going to be undefined. Then I get 1, 1/2, and 1/3. Just a heads up for this lesson, we are going to have to get familiar with fractions. We're going to have to get used to them. All right, so I'm going to grab this, and we're going to go to our next slide. And now we're going to graph these points. So we're just going to have to estimate when it comes to these fractions. All right, it's not going to be exact, and that's fine. I cannot go through 0, right? So I'm not going to plug in 0 to graph that. So we have -3, -1/3, so that's like a little bit right there. -2, -1/2, it's a little closer to the middle. -1, -1. I'm not allowed to have x is 0, so that means it's not going to cross that. So what happens here is these points are going to end up shifting and going like this. Get real close to it, but never cross it. And they're going to go this way as well. So now let's try these. We have 1, 1, 2, 1/2, and 3, 1/3. So again, we're going to get real close here, but never cross it. We're going to get real close here and never cross it. So this is actually the graph of a rational function. Right? It's two different parts to it. There's lines it will never cross. Right? And they're going to hug those lines but never actually go over them. So all rational functions are the form p of x over q of x, where these are both expressions, polynomials, and the bottom cannot equal 0. So those lines that it doesn't touch are called asymptotes. So it's a line that a curve approaches as it heads towards infinity. So in our previous problem, the line y equals 0 and x equals 0, or the x and y axis, would be considered our asymptotes because it's never ever going to cross those lines. Right? They're going to get really close but not cross them. And this is just something to know. The inverse variation function, f of x equals a over x, is a rational function. We're not going to worry as much about that. So here are some steps for what we're going to do. We have our parent function, right? That's the one we just graphed. This graph is actually called a hyperbola. So we know that a graph that looks like a U was called a parabola. This is a hyperbola. Then we have two asymptotes always. We have a horizontal asymptote, the one that goes left and right. So for the parent function, it's always going to be y is 0. And we're always going to have a vertical asymptote. And for the parent function, that's going to be the y-axis, or x is 0. So the domain then would be all real numbers that don't equal 0. And the range is all real numbers that don't equal 0. Or really, that just don't equal our asymptotes. So for each of these problems, we're going to identify our vertical and horizontal asymptotes, and we'll draw them on our graph with some dashed lines. We'll make a table of values of points on both sides of the asymptote. We'll plot those points, and then we'll draw the two branches of the hyperbola. So we know that 0 can't go on the bottom, so 0 is our asymptote, right? We already know this is like the parent function, so 0 will be the asymptote. So let's draw some lines on here. I don't think that's what I wanted. That's what I want. Let's go blue. All right, so we know that's one of our asymptotes, and that's one of our asymptotes. Sometimes it helps me to write what they are. So my vertical asymptote, the one going up and down, was x equals 0, and my horizontal asymptote, the one going left and right, was y equals 0. So now I'm going to plug in negative 3 for x. So 4 over negative 3 is negative 4/3. And if you're more comfortable writing it as a mixed number, that's negative 1 and 1/3, right? Might be easier to see where you're plotting it if it's a mixed number. When I plug in negative 2, 4 over negative 2 is negative 2, and 4 over negative 1 is negative 4. So I already know this branch of the hyperbola can be graphed as negative 3, negative 1 and a third, negative 2, negative 2, and negative 1, negative 4. So we're going to get really close to this line but never cross it. And then we're going to get really close to this line and never cross it. I will tell you the things I look for when I'm looking at your graphs is I'm making sure you're not curving the arrow back, right? It shouldn't be ever curving back around, and that it doesn't cross the lines you drew. All right, let's look at the other part now. 4 over 1 is 4, 4 over 2 is 2, and 4 over 3 is 1 and 1/3. So we have 1 comma 4, 2 comma 2, and 3 comma 1 and a third. All right, and that's our hyperbola. So you go ahead and try this one, pause it, and I will show the answer. All right, so here's your answer. Check it over. All right, so now we're going to graph simple transformations of that. So what's going to happen is we're still just going to have a plain number on the top, but the bottom is going to be x plus or minus something, or just x, but x plus or minus something, and there can also be something afterwards. So this is now going to affect our asymptotes. They're no longer going to be x equals 0 and y equals 0. My horizontal asymptote is now y equals whatever number's on the outside. So if there was no number, it would stay 0, but as soon as there is a number, it becomes that. My vertical asymptote is going to be the opposite, basically, of whatever's down here. So if it was x plus 1, it would be negative 1. If it was x minus 5, it would be positive 5. So it's going to be x equals whatever would make the bottom 0, basically. So now our domain is all real numbers except what was my vertical asymptote, and my range is all real numbers except what was my horizontal asymptote. So I'm going to right away figure out my asymptotes. So I know my vertical is the one that makes the bottom 0. So if this is x plus 2, that's x equals negative 2. And my horizontal asymptote is going to be y equals whatever number's out here. So y equals negative 1. So I'm going to go ahead and graph those two lines. X is negative 2, and y is negative 1. Oops, let's move that over a bit. There we go. So now that I know that x is negative 2 is my vertical asymptote, I'm going to put that in the middle as undefined. That's the one I'm not going to graph. So now I'm going to pick some numbers before it. So before negative 2 would be negative 3, negative 4, and negative 5. And then I'm going to pick some numbers after it. So there'd be negative 1, 0, and 1. And now I'm going to substitute each of them in for x. It might help to show some of this work. So we have negative 4 over negative 5 plus 2 is negative 3 minus 1. So that's 1 and a third minus 1. We get 1/3. Then we'll plug in negative 4. So that's negative 4 over negative 4 plus 2 is negative 2 minus 1. So this is 2 minus 1, or 1. Then we have negative 3. So we're going to get negative 4 over negative 3 plus 2 is negative 1 minus 1. So that's going to be 4 minus 1, or 3. And then we're going to plug in negative 1. So that's negative 4 over negative 1 plus 2 is 1 minus 1. So negative 4 minus 1 is negative 5. Negative 4 over, let's plug in 0. So that's 0 plus 2 is 2. So that's negative 2 minus 1 is negative 3. And then lastly, negative 4 over 1 plus 2 is 3 minus 1. So that's negative 1 and a third minus 1 is negative 2 and a third. All right, so we're going to plot these. So we have negative 5 comma 1/3. 1, 2, 3, 4, 5, 1/3. Be careful that you're still counting from the origin. You don't accidentally count from the asymptotes that you drew. So negative 4, positive 1, and negative 3, positive 3. All right, there's one branch. And then we have negative 1, negative 5, 0, negative 3, and 1, negative 2 and a third. And the last thing we have to do is talk about the domain and range. So really, these asymptotes that I had are going to help me with that. So my domain is going to be all real numbers except x does not equal negative 2. And my range is going to be all real numbers except y does not equal negative 1. All right, so I'm going to take those two asymptotes and I'm going to say they don't equal them in my domain and range. All right, you go ahead and try this one, and then I'm actually going to have you try two more after this. So try this one. I'm going to go ahead and pause, and I'll show the answer. All right, go ahead and check your answer for this one. All right, there was nothing being added or subtracted underneath, so it got to be x is 0 is the asymptote. But we still had a number on the outside, so that was our y asymptote of negative 2. Go ahead and try this next one. Pause it, and I will show you the answer. All right, go ahead and check your answer for this one. Negative 4 is what would give us our vertical asymptote. Right, so negative 4 is undefined. There was no number after it, so that gives us a y of 0 as our horizontal asymptote. All right, and one last one for you to try. Go ahead and pause it, and I will show the answer. All right, here's our last one. We had an x can't equal positive 1, so that was our vertical asymptote. And then y couldn't equal 5, that was our horizontal asymptote. And that is day 1 of graphing rational functions.